Okay, let's get started. Then we are on to this exercise. In the following code, determine the type of each variable and each variable, the value each variable has when the code finishes. Okay, so this will be an uh, int c, right, and int c. Then I want int ref d. Okay, great. Okay, so c increases value of c, but d increases value of a. Okay. Assignment is an example of an expression that yields a reference type. Okay, yeah, I think I did learn about that. Assignment, right? No, it didn't. Okay, right. Assignment is an example of an expression. Save on my computer. Remember my choice. Save. Unable to save. Please check the folder permission. Try saving the folder with a different name. Huh? Okay. Okay. And is it just gone now? Man. Bro, what happened? Okay, right. I was afraid for a while. Location of file, your computer. Okay, so if I make int c and then ref d and I try to save it, please check the folder permissions. Properties, permission, read and write, yes. Access, read and write. Okay, access, read and write. I don't hold up. Okay, so I have this int c and let me make its color to light blue. Yeah. Okay, so this is int c and then this is int, and these are the types. Okay, then assignment is an example of an expression. Assignment is an example of an expression that yields a reference type. The type is a reference to the type of the left hand operand. Type of the left hand operand, that is, if I is an int, then the type of the expression I equals is int. Okay, using this knowledge, determine the type and value. First of all, this is where is highlight. Yeah. Using that knowledge, determine the type and value that each variable in this of each variable in this code. Okay, so we have int. I can go. See, this is c. int c, and then this will be int ref d, right? Okay. Then describe the differences in type deduction between decal type and auto. Okay, see, auto drops the top level consts, and decal type does not do so. Also, yeah, so const and reference, and it also auto also drops type modifiers, I think. Let me take a look. Right, since here the pdf const, change. Okay, we can also specify we want a reference to auto deduced. Okay, five compound type auto. Okay, so auto, it is not common. Okay, so by implication, a variable that uses auto as its type must has an initializer. Okay, auto must has an initializer, and decal type doesn't need to have an initializer, I don't think. And as with any specific, we can define multiple variables using auto, but because a declaration involves a single base type, the initializer variable, right? Okay, so this is a variable that uses auto must have an initializer component. Then when we use a reference, we really using the object to which the reference refers. In particular, when we use a reference as an initializer, the initializer is a corresponding object. Okay, the compiler uses the object's type for auto's detection. So A is an int. Second, auto ordinarily ignores top level const. As usual, initialization low level const just are kept. Okay, so if it is a pointer or a reference, okay, initializer the const are kept. The base type is important in this case. Okay. So end of ci, so it is a pointer, right? Air type reduced int constant, right? Okay. So we have the sticker type, right? So let's see. Let's start with right. Okay, so we have auto. We say auto. Variables where using auto must be initialized, and and then we will say decal type. Decal type. There is no such implication, right? Decal type C, yeah. There is no such implication, right? Then with auto, it usually drops the top level consts. It keeps them, right? Initialize. Okay, if you want the expression non-reference type, okay, decal type, right? Okay, the compiler analyzes the expression, determines its type, but does not evaluate the expression. Okay, here the compiler does not call f, but it uses the word return compiler. The decal type handles top level constant reference different. An expression to which we apply decal type is variable. Decal type returns the type of that variable, including top level const and references, right? So CJ is a constant reference. Okay. It keeps them along, even if it is with references. And what else? You have to explicitly define uh, consts and references in case of auto. There is no such need as it can automatically reduce the type, right? Right. Okay, defining our own data structure. Now we move on to defining our own data structure. Okay, right. At most basic level, a data structure is a way to group together related items and a strategy for using those data. You can highlight, yeah. As one of the example of sales item class and ISBN, a count of how many copies of that book had been sold and the revenue associated with those values. It also provides a set of operations such as ISBN function, this is equal to operator. In C++, we define our own data types by defining a class. The library type string, stream, OSTream are all defined as classes as a sales item. Okay. Okay. C++ support for classes is extensive. In fact, part 3 and 4 are largely devoted to describing class-related features. Even though the sales item class is pretty simple, we won't be able to fully define that class until we learn how to write our own operators in chapter 14. Okay. Defining sales type data type. Although we can't write our sales item class, we can write a more concrete class that groups the same data element. Our strategy for using this class is that users will be able to access the data elements directly and must implement needed operations for themselves. Okay. Because our data structure does not support any operations, we'll name our version sales data to distinguish it from sales item. We'll define our class as follows. So this, a class begins with a keyword struct followed by the name of the class and a possibly empty class body, right? So the class body surrounded by curly braces forms a new scope. The names defined inside the class must be unique within the class but can reuse names defined outside the class. Okay. The closed curly braces that ends the class body must be followed by a semicolon. The semicolon is needed because we can define variables after the class body. Okay, so we struct sale acom trans sales pointer. Okay, this is, bro, this I like this. Equivalent but better way to define this object is sales data, then we go acom. Okay, the semicolon marks the end of usually empty list of declarators. Ordinarily, it is a bad idea to define an object as a part. Okay, ordinarily, it is a bad idea to define an object as a part of the class definition. Okay. Doing so obscures the code by combining. Wait, let me go highlight and text is light blue. So doing so obscures the code by combining the definition of two different entities, the class and a variable, in a single statement. Okay. It is common mistake among new programmers to forget the semicolon at the end of class definition. Okay, class data members. The class body defines the members of the class. A class has only data members. The data members of the class define the content of the objects of the class type. Each object has its own copy of the class data members. Okay. Modifying the data, right? Write comments, no. Okay. Right, the class body defines the members of the class and our class data members. Oh shit, no. This is not right. It needs to be dark. Mm. Each data, each data object has its own copy of the class data members. Modifying the data members of one object does not change the data in other sales data object. See, that is important. Okay. So we define data members the same way we define normal variables. We specify a base type followed by a list of one or more declarators. A class has three data members: a member of type string named booknum, an unsigned member named unit sold, and a member of type double named revenue. Each sales data object will have these three members. Under the new standard, we can supply an in-class initializer for the data members. When we create objects, the in-class initializer will be used to initialize the data members. Members without an initializer are default initialized. Okay, right. Within a block, they can have any value, and outside the block. Thus, we define sales data object unit sold will be initialized to 0 and book num will be initialized to an empty string. Okay, default initialized. Yeah. Nothing, sorry. Just this. I didn't mean to. Can I select the color? What is happening? Okay. Empty string. Hey, is Adobe Acrobat here? Let me try Acrobat. Wine, no. Adobe. Hey, WPS Office, is there WPS Office? Insufficient ports. Poor support. Confinement district. Okay. That's okay. The in-class initializers are restricted as to the form. 221 page 43. They must be either enclosed inside curly braces or follow an equal to sign. Okay. Struct foo empty note no semicolon. This will give an error. Okay. They must be enclosed inside curly braces or follow and we not specify an in class. Okay. In 7.2 page 268, we'll see that C++ has a second keyword class that can be used to define our own data structure. We'll explain in that section why we use struct here. Until we cover additional class related features in chapter 7, you should use struct to define your own data structure. Okay, compile the following program to see what happens when you forget the semicolon. Okay, let's try that. Sublime text. Should I okay, let me see if CPP. Right, CPP. Let me just take a look. MI roundabout type aliases. Right. Okay. About type aliases, and I have. Why doesn't it show? Oh, because okay, right. Okay, web development. I think I need to pull. No. Yeah. Okay, we'll do that later. So for the time being, I will go exercises. This is exercise. Exercise 2.6.1. Okay, so you create a new folder. Exercise 2.6.1. You go inside. Terminal. Okay. Let's do that. Maybe make a new file. Maybe I'll say 2.2.3 CPP, and we'll open that here. Okay, so we create a struct foo. We start its body, and it is empty. Okay, so it says what error does it give. So we'll go C++ 2.39 CPP. So it provides this error. It throws the following error. Right. Okay, then we write your own version of sales underscore data class. Okay, that's okay. I can do that. Let's go here. I think it will be 2.40. 2.40. CPP, and then I want to open sub. We go struct sales data, then we have a string name number, then we have unsigned integer units sold equals 0, signed units sold equals 0. Okay, these are this is an in class initialization. Then we have double revenue. 0. There you go. Okay. Then using the sales data class. Unlike the sales item class, a sales data class does not provide any operations. Users of sales data have to write whatever operations they need. As an example, we write a version of the program that prints sum of two transactions. The input of our program will be transactions such as these. Okay. So sales data dot h. Ooh. Let's open it up and let's copy it here. It says pragma once. I feel like I have to string. Yeah. Now I don't need to use, I don't know, but we'll use it anyways. Okay. So we go because sales data provides no operation. Okay. We'll assume that sales data class is defined. We'll say okay, because this program will be longer than any we've written so far, we'll explain it in separate parts. Overall, our program will have the following structure. Okay, so sales data objects. I think this is not an exercise, and defining header files. Well, the preprocessor directives. Okay, if not defined. Okay. Code read data 1. Reading data into sales, printing the sum, writing our own header files. Introduction to the preprocessor. Okay, so we will use this. Okay, so we will close it here. Okay, this got to be 13, and I will create a new folder. Adding sales data object, right? Adding two sales data objects, right? Okay, so we go in here and I want the terminal here. Okay. Okay. Script.cpp. Okay, sales. So we go. If not defined, sales data h, then define sales data h and if. So go include string and then everything else. Okay, so we struct sales data, string book number. Then we unsigned integer units sold equals 0, and then revenue 0.0. Okay, so there we go. The program, because this program will be longer than any program we've written so far, we'll explain it in separate parts. Overall, our program will have the following structure. Okay, so this is the main file. Let me create and subl main.cpp stream include shrink, and we will include our sales data.h file. Okay, as in our original program, we begin by including the header, will need, and define variables to hold the input. Okay, note that unlike sales item version, our new program includes string header. We need that header because our program will have to manage book number member, which is a type string. Shit. Okay, nope, I don't need that. Yeah, let's close that. Delete. Okay. Note. Oh, but it was a valid node, right? Yeah. Okay. So let me download it once. Not download it. Let me print it so that all the variables are saved. Save. Go to home, GitHub, CPP Primer, and this save. Just replace. Okay. So we have replaced. Now, yeah, leave. Okay. Now, if I open it, open with Brave browser. It should, yeah. Okay. Okay, great. Okay, so we defined two objects, sales data, data1 and data2. Okay, we declare two sales data objects or variables. Sales data, data1, data2. Then code to read data into data1 and data2, code to check whether data1 and data2 have the same ISBN number, and if so, the sum of data1 and data2. Okay. Reading data into sales data object. Although we won't describe the library string type in detail until chapter 3 and 10, we need to know only a little bit about strings in order to define and use our ISBN number. The string type holds a sequence of character. Its operation include that's output stream operator and input stream operator, and is equal operator to read, write and compare strings. Okay. respectively. With this knowledge, we can write the code to read the first transaction. Okay, double price equals 0. Price per book used to calculate total revenue. Before we declared, and code for reading data into data1 and data2 objects. So first we define a double price equals 0. Price per book used to calculate total revenue. Price per book used to calculate total revenue. Then read the first transaction, ISBN number of books. Okay, ISBN, number of books sold, and price per book. Okay. So read the first transaction, ISBN, number of books sold, and price per book. Okay. So we go stdcn. First we take the data1 dot book number. Then we take, what is this, units underscore sold, score sold, and then finally we take the price per book. Okay, right. Then calculate total revenue from price and units sold. Then calculate total revenue from price and units sold. So data1 dot revenue equals price times units sold. data1 okay. A transaction contains the price at which each book was sold, but our data structure shows the total revenue. We'll read the transaction data into double named price, from which we'll calculate revenue. The input statement book number use the dot operator to read into book number. Okay. To read into the book number and unit sold members of the object named data1. The last statement assigns the product of data1 dot unit sold and price into revenue. Right. Our program will next repeat the same code for data2. Okay. So we'll go repeat for data2. So data2 dot book number, right, book NO, book number, then data2 dot units sold, and then price, then data2 dot revenue equals price times data2 dot units sold. Printing the sum of two sales data object. Our other task is to check the transaction that the transaction are for same ISBN. If so, we'll print the sum, otherwise we'll print an error message. Okay. If total count equals 0, it's not 0. Okay. There's no sales. Data must refer to same ISBN. Then -1 indicate failure. Okay. So we check Then what is the code to check whether data 1 and data 2 have the same ISBN. Okay. Code to check whether data 1 and data 2 have the same ISBN, and if yes, then print their sum. Okay, so if data 1 dot book number equals data 2 dot book number, then we go for int total count. I think this is it. Okay, unsigned, of course, unsigned total count equals data 1 dot units sold plus data 2 dot units sold, then double total revenue, right? Total revenue equals data 1 dot revenue plus data 2 dot revenue, and then print ISBN, total sold, total revenue, and average price per book. Okay, total revenue, total sold, ISBN. Okay, revenue and average price per book or total count. Okay, then print ISBN total sold, right? Total sold, total revenue, and average price per book. See out. So data 1 dot book number, then total sold are total count, then we have total revenue, then if total count is not 0, if total count is not 0, then we print total revenue over total count, else no sales. Okay. Else we write no sales. And yeah, okay, and if data 1 and in the end we return 0, else we log an error, indicate success, thus indicates success, then to the standard error, data must refer to the same ISBN. Data must refer to the same ISBN, and then we transaction warrant for the same ISBN. Transactions warrant for the same ISBN. And return -1 indicates failure. Okay. Alright, so let's try and make it. Are you? Yep. Okay, so we go make main total count. Right. Total. Okay, so we provide I say S is the name of the book. Then we want the units sold, say 5, and each of at price 10. Then say S was 4 at price 10 again. So we had S, total units sold, total revenue is this, and this is the average price per book. Okay. So there must be spaces, but they have provided spaces. And that should be much better. Okay, so we go S 5 10, S 5, S 4 10. Right. So S9, total revenue is 90 and average price per book is 10. Okay. So there we go. Let's just main. And okay, that's that's enough. Right. Okay. In the first, if we compare the book number, members of data 1 and data 2, if those members are the same ISBN, we execute the code inside the curly braces. Right? That code adds the components of our two variables. Because we'll need to print the average price, we start by computing the total unit sold and revenue and store it in total count revenue respectively. We print those values. Next we check that that there were books sold. If so, print the computed average per price. If there was no sale, print the message nothing, noting that fact. Okay. Then we have using your sales data class. Use your sales data class to rewrite an exercise 1.5.1 and 1.5.2 and 1.6 for now. You should define you in the same file as the main function. Okay, that is okay. Let's copy these and exercises. This is exercise 2.6.2, exercise 2.6.2. Okay, so let me print it, save. I don't need a preview, I just need to save it. Yeah, replace. Then let me see. Nope. What about the bookmarks? Where did the bookmarks go? Nope. Man. Hold up. Leave. Right. Close it here. Okay. So far so good. So we go here to the book and we open with this browser. I think it should give me bookmarks. There were bookmarks before. Huh. Dude, what have you done? Pages. Um. Okay. Page number one. It was like 1.6 something. 1.3, 1.4. Go 1.4, 1.51 exercise. I need exercise. Okay. Page number 24 or 25 was it? Okay, so I have to do these exercises. And 1.51. And working directory is a program that reads a set of book transaction, reading each transaction to the standard output. Okay. Write a program that reads two sales item objects that have same ISBN and produce their sum. Yeah. Okay. Write a program that reads several transactions for the same ISBN. Write the sum of all transactions that were read. Okay, so I should start with what? Okay, I need to drink water. Okay, so let's start with write a program that reads two sales item projects that have same ISBN and produce their sum. Okay, so we have done this, right? We have done this. Let's say rename it to 1.2.1. 1.2.1. 1.21. Say 1.21 there. Okay, then I have to write 1.22. Which 1.22 dot CPP. And then I can open it up here. Okay. So write a program that reads several transactions for the same ISBN. Write the sum of all transactions while they were read. Okay, several transactions for the same ISBN. And write the sum of all transactions that were read. Okay, this is very similar. I will go sales data, right? Then while cn data dot book number, right? Then we'll go current equals std string current equals data dot number. We define current number. Okay. I feel like study CN, we have to keep reading the book number. Previous. Right, okay. So I think I will put my brain into it later. For now, we call it a day.